Okay, so this example is about hypothesis testing for correlation. So we've got a scientist taking 30 observations of the masses of two reactants in an experiment, which calculates product moment correlation coefficient of R equals minus 0.45. The scientist believes there is no correlation between the masses of the reactants. Test at 10% level of significance, the scientists claim, stating hypotheses clearly. So the first thing to understand is that the value of R we've got there is from the sample. So that's why it might seem strange that a scientist is believing there's no correlation when quite clearly there is some negative correlation there. However, that negative correlation is just for the sample, and that might not be repeated if she took more observations. And so that's where the hypothesis test bit of this comes in. So for a hypothesis test for correlation, you need to have a table of values, so critical values for the correlation coefficients. So this is within the form of the book, and it's probably in most textbooks as well. So when you're doing a hypothesis test, it's obviously really important you state your hypotheses clearly. So in this instance, hypotheses are null hypothesis that rho is equal to 0, and that is always the case. So whenever you're doing a hypothesis test for correlation, the null hypothesis is always rho equals 0, never anything else. The alternative in this instance is that rho does not equal 0, and that's because the question is whether or not there is correlation. It's not talking about positive or negative correlation. Obviously, if we had positive or negative correlation, it'd be like rho is greater than 0, rho is less than 0. In this case, no correlation, so it's just not equal to 0. We've got a 10% level. It's a two-tailed test. So as with other types of hypothesis testing, if it's two-tailed, we have to halve that significance level. So we end up with 0.05. So with the table, there's two things that are important here. One is that this value we've got, the significance level we're using, 0.05, and the fact that there's 30 observations. So the table is this. The right hand side we're not worried about, that's Spearman's rank. That's not something that's something that you're going to be assessed on in A-level maths. So we've got significance level 0.05, so find that up there. We've got 30 observations, so we have to go all the way down to 30. So if we look that up, we have found that we end up with this value here, so 0.3061. So that's the critical value. So let's make a note of that. So the critical value, I actually think say values here because we want to test it for positive or negative correlation. So those are the critical values. The value the scientists calculated from the observations was minus 0.45. That's less than minus 0.3061, or more significantly, it's further away from 0 than minus 0.3061. So that means that this result is significant. We've ended up with, or the scientist has got a correlation coefficient from the sample that is further from 0 than the critical value. That means that she does have evidence that there is correlation. So the answer to the question would be that we're going to reject H0, and we're going to say there is evidence at the 10% level of significance that there is, and then you want to refer to what's in the question actually. So there is what? So there is correlation between the masses of the two reactants. So just quote what's in the question to make your life easier than trying to figure out what's going on with masses and reactants and so on. So you don't need any scientific understanding here. So there is correlation between the masses of the two reactants. That's all we need to do.